Got it. Now we're live. I think Professor Brown's going to use the default echo capture thing. I don't think he has a choice. I think everybody's using that. And it's probably on right now, but I don't know where the camera's pointed. I don't know where the mic picks up from. And I don't typically like the quality of the echo capture, so I always use YouTube. So this is live on YouTube now. I'll send you the link. You can go watch it later. Today I want to talk about, well, what's this class about? Does anybody know? Oh, and I'm not going to use any PowerPoint slides. I'm not going to use any Google Slides. That could have been my way out to use Google Slides instead of PowerPoint, because you will get plenty of PowerPoint slides when Professor Brown gets back from Paris. What's the class about? Does anybody know? Who has read the course description for this class? Raise your hand. Be proud. Be proud. Raise your hand. Who has not read the course description for this class? In the back row, why'd you take the class? That's not... You may have backed yourself into a corner where this is the way you've decided to get out of the corner, but it is not required for any major. It's just one of the ways to fulfill course requirements for several of them. Somebody else, who else has not? Why'd you take the class? Your friend took the class and it sounded cool. Yeah, I took a lot of classes that way. You know what I used to do? So it used to be at the bookstore. They had books like on shelves. And you could walk up and down the rows and you could look at the textbooks. And it would say underneath the textbook what class that book was for. And I used to go look at the books. You're like, that looks interesting. And I would take like one of the used ones down and I would flip through it. Say, yeah, no, I don't want to learn that. Put it away. So I often chose classes without looking at the course description also. If you have looked at the course description, you will clearly see that the title of the class was made by a committee. Could anybody say all the words in the title? No, that's a lot of words, right? And the course description was crafted a little bit better than the title. So somebody who has read the course description, tell me what the class is about. There's like 3 or 4 keywords in that course description. I mean, there's 2-3 paragraphs, but there's really only 3 or 4 words. What's the course about? Needs to be a little more interactive than this. In the back. Yeah, Professor Brown wants to change the name. I asked him what's the point. He wanted to call it what? Manufacturing Engineering 101 or something like that. Yeah, Intro to Manufacturing. I always refer to the class as an introduction to manufacturing. So when people say, what do you teach? I say, well, I teach a class in the Introduction to Manufacturing, even though the title of the class is like this long. It's one of the only classes that actually doesn't fit in the course catalog. They have to abbreviate some of the words to fit it in the course catalog. So manufacturing is one of the words. And after all these years, it's one of the few words that I still know how to spell. So manufacturing, what else do we talk about in this class besides manufacturing? Yes, WPI football. Prototyping is another one of those words. Which I suppose is often sort of a form of manufacturing. What else is a key word in that course description? You could Google it. Yeah. CNC machining. And so today I want to talk about manufacturing, CNC machining, and prototyping. Okay, that's really the key. That's what the class is about. I think I counted once. The word manufacturing appears in that course description like 9 times. The CNC machining or CNC is more than that, and prototyping is sprinkled throughout. So unless I did count. I did like a little histogram once. It's like geeky, nerdy engineer stuff. Oh, I heard the best dad joke ever. You guys will get it. Ferris wheels are made primarily from steel. If they were made from aluminum, they would be non-Ferris wheels. It only works on a certain crowd. So we're going to talk about manufacturing, CNC machining, and prototyping. What is manufacturing? So manufacturing is the overriding thing here. These are components of manufacturing. What is manufacturing? What does it mean to be a manufacturer? How do you manufacture? So it's a verb, it's a noun, right? So when we are manufacturing, we take raw materials, and we have a product, and in between, there's a process. So raw materials into the box, product out of the box. So when we do manufacturing, we take raw materials, we do something to them. This process adds, that's 2 D's on add, right? It's helping my 10-year-old with spelling words yesterday. Now, when I was in the 9th grade, my teacher sent home a note with my report card. He said that he's a joy to have in class. Very intelligent, possibly the worst speller I've ever met. So she had connotation as a spelling word. 5th grade, connotation. And denotation. You couldn't say denote. You had to say denotation and use it in a sentence. Yeah. I can't spell, getting back to that. So we're going to add value. So if I spell add incorrectly, it just means that I also make the other kind of adds. So take raw materials, add value, we get a product. So does this define manufacturing for us? If we wanted to say it without making a flow chart, how could we say what manufacturing is? So this part right here is like making, right? Is this making? Who's ever been in a makerspace? Most of you have been in a makerspace. What type of equipment do they typically have in a makerspace? Yes. 3D printers, laser cutters. I've seen CNC machine tools. I've seen all kinds of stuff in makerspaces. They typically have manufacturing equipment in makerspaces, right? What's the difference then between making and manufacturing? Yes. Yeah. Exactly. So he says that manufacturing or making is doing something for yourself. Whereas manufacturing, there's some intent with what you're doing. The only difference between making and manufacturing is when you're doing manufacturing, you intend to sell the thing you're making. That's what makes it manufacturing. So it's making stuff with the intent to sell it. And so when I teach the class and when I have you for the entire series of lectures, we bring that theme up repeatedly, and I end up talking about the business of manufacturing as well as the making of manufacturing. Because if you don't understand something about the business of manufacturing and you go work at a manufacturing company and nobody there understands the business, ain't nobody going to be working there very long because it's going to fail, right? So I will focus on that. Professor Brown, I think, is going to focus more on the sciencey and engineering side of manufacturing. If you want to talk more about the other side, you can always find me in the lab. Maybe not always. I'm usually not there after about midnight or before about 5 a.m. So between midnight and 5 a.m., it's going to be hard to find me in the lab. Other times I'll be hiding, but I might be there. Okay, so manufacturing is making stuff with the intent to sell it. So CNC machining then. What's CNC machining and what does it have to do with manufacturing? Actually, hold on. Let's back up for just a second. Think about that. Think about what's CNC machining, what's it got to do with manufacturing. Let's just take one step back. Why do we care about manufacturing? Well, because you need to graduate, right? Why do we care about manufacturing? Somebody over here started to talk. It makes everything we use. What's your name? Isaac. Does anybody disagree with Isaac? You've got something to add, or you disagree? Okay, so there's some of us that make some stuff for ourselves. Isaac, do you have an argument to refute that?
I disagree with myself.
Oh man.
I expanded it and said that it makes everything we use, which is obviously false. But like the tables, the chairs, anything that's
Anybody eat an apple today?
bought and purchased.
Did anybody eat an apple today? Really? You did? Okay. You just giving me that? Or did you actually eat an apple today? What kind of apple was it? Yeah. Like a round one. Quite large, yeah. So he had an apple today. He used it, right? Did manufacturing impact his ability to eat that apple? It guarantee it impacted his ability to eat that apple today. It's possible he was bebopping through the orchard and he picked an apple off the tree and ate it. It was still impacted by manufacturing, though, because the farmer that planted those trees drove a tractor. I guarantee it. And so there's nothing that we do in everyday life that isn't somehow impacted by manufacturing. They say something like roughly 20% of the US economy, the US GDP, comes from manufacturing. But that's when they're looking directly at companies who proclaim that they are manufacturing companies. All the stuff you bought at the store came from manufacturing too. That means all retail is dependent on manufacturing, right? There's very little bits of our economy, of our society today that don't depend on manufacturing. Therefore, whether you believe you're going to work in manufacturing in the future or not, understanding about manufacturing is going to be important to you in the future. Okay, so back to CNC machining. CNC machining. So that's one of the three things this class is about, is CNC machining. It's going to be one of the, it all is manufacturing. So really it's one of the two things this class is about, because the class is manufacturing. Why do we focus so much on CNC machining and what is it? You can answer either question. Yep.
Why do we focus on it? It's one of the largest types of modern manufacturing.
So he says it's, what's your name? Chris. Chris says that it's one of the largest types of modern manufacturing. And so by largest, you mean? Could we call it most prolific? Is that a, I'm supposed to, I'm on YouTube though. I'm supposed to not talk about 5th grade words. Well, shit, denotation is a 5th grade word, so I guess prolific too. So largest prolific type. And so CNC machining is a process, right? Over here, we said we take raw materials, we apply a process to them, we get a product out. And so CNC machining is a process that we apply, that we use to add value to stuff. And I would say that it is the most prolific process in manufacturing used today. Why do I say that? First off, do you guys know what CNC machining is? I see some head nods. Anybody willing to admit they don't know? You're willing to admit that you may need more knowledge about it? So machining is it's the process of removing material to make the thing be the shape you want it to be. And so there's a famous thing. The art student asks the teacher, how do I carve an elephant out of this block of stone? And the teacher says, well, just take away everything that's not elephant. But that's exactly what CNC machining is doing. So you have a thing that you want. And so who's had lab? About half of you have had lab, right? In a lab, we made the Y block for the thermoacoustic engine that we're going to make in the class. And so you started with a rectangular prismatic piece of material. You put it in the machine tool, and then you tightened the vise, right? We did that part. And then we had to use a torque wrench to make sure the vise was tight. Anybody remember what the torque wrench was set to? I said it in the video. 40 foot-pounds. Anybody know how much clamping force that gets us in that vise? About 3,000 pounds of force. So we take that piece of aluminum, we squeeze it with about 3,000 pounds of force. Why is that? Why do we, 3,000 pounds of force seems pretty excessive. It would certainly hurt your finger, right? So why so much force? Yeah. Yeah. So the spindle is rotating, right? And the tool is attached to the spindle. And as that tool is rotating and it comes in contact with the workpiece, I actually had to. I called the manufacturer. I called their service area because we were going to do something that was non-standard with the machine. Believe it or not, at research universities, we do some non-standard things with the machine. And I asked him if we could. I can't remember. We were gonna push on something with a couple 100 pounds. I just want to make sure it wasn't going to damage the spindle. And I knew it wasn't intuitively. I knew it wasn't, but I had to ask him, and he just laughed. He says, "Those spindle bearings can take thousands of pounds of thrust, right? Because that cutting force that gets generated at the cutting edge of the tool as it's spinning around, moving through the material, could be thousands of pounds." And so typically, in the range of up to 1,000 is what we see cutting forces in those machines. So we're clamping on that thing. What keeps the part in the fixture when we clamp it? So that cutting force is actually mostly sideways and up. Unless you're drilling. When you're drilling, some of it's down. It's mostly sideways and up. What keeps the part from flying out is the friction between the vise jaws and the workpiece. How do you get more friction? Change the friction constant, right? Change mu. So change the materials or squeezy more. Yeah, so we added we've been doing this lab for a long time. And we added the torque wrench after the third broken glass door on the mill. Well, because it's your first time seeing a machine tool, right? For many people, it was the first time being in front of a machine tool. If nobody tells you how tight to tighten it, and you weigh like 95 pounds soaking wet, and you're jumping up and down on the handle, it might not be enough, which we have experienced with some students of minor stature, right? My wife weighs about 95 pounds, and I eat all the food in the house. But she would stand up there and try to crank on the vise, and then she'd have somebody come tighten the handle for her. So yeah, that torque wrench is in there so that we know that you're putting sufficient, and it's got that long lever arm too, right? And Archimedes taught us that long lever arms are good. You could actually break the vise with that torque wrench if you set it up too high. So, all right, there we go. So CNC machining, so we got that cutting tool, goes through the material, chips come off, and so we typically think of CNC machining as milling and turning. So in milling, the tool rotates, right? And then it moves side to side and up and down relative to a workpiece. Now, in the machines that we're going to use in lab, the tool spins around and it moves up and down. And then the workpiece is fixed to a table that moves in X and Y. We also have rotary tables that we can put on the XY table, so we could move the workpiece this way and this way while moving it in X and Y. And so we can do 5-axis machining in those machines. And so you can make, with that type of process, you can make prismatic shapes, right? So you can make stuff that you can see from the top down. So that's milling. And it is from the spinning of the tool that all the cutting happens. The moving side to side is what positions it where there's material to be removed. And so when it's the spinning, we call that the speed. And when we're moving from side to side, the velocity of moving from side to side, we call that the feed. And you'll hear all these terms, especially as you get in the labs. I think one of the important things with any of these engineering classes is to learn the jargon or the technobabble. And it's very important, especially as young engineers entering industry, if you're going to talk with manufacturers. If you go there and you know how to speak to them and you ask them for their advice, they're willing to help you. If you go there as an arrogant, know-it-all, pain in the ass engineer, and you say, I need you to make these parts and I need them right away, their favorite thing to do is make you exactly what you asked for, especially if they know it won't work. Right? But if you can have a conversation with them, they'll help you out, because these, I call them, affectionately, I call them cranky old machinists. These cranky old machinists, some of them may be younger than you, but when you're dealing with them, they're cranky and old. They have seen a lot. They've made a lot of stuff. They've seen how stuff fails to work, especially parts that are supposed to go together that don't fit together because you guys screwed up the design. And by the way, when the parts don't go together, it's on you. You're the designer. You decided how big to make the parts. But if you're nice to them, they'll help you and they'll fix those mistakes before you have to tell your boss about it. And if you're not nice to them, they will ship the part and charge you. And then they will charge you extra to fix the part. All right, so anyways, learning stuff. CNC machining. So that's milling, right? Milling is when the tool spins. In turning, we typically do milling in a milling machine. Often it's a CNC milling machine. Sometimes they're called vertical machining centers, VMC. You'll hear that also. So a vertical machining center is a milling machine. You may also have a horizontal machining center. But as long as the tool is spinning and the workpiece is moving relative to the tool, or the tool's moving relative to the workpiece, but the tool's spinning, as long as the tool is spinning, it's a milling operation. So turning operations we typically do in a lathe. I know of one corporation in the world where they call the process lathing. At Bausch & Lomb, they call it lathing. Everywhere else in the world, they call it turning. In turning operations, so if you say lathing and you don't work at Bausch & Lomb, you're going to look weird. They're going to know you don't know what you're talking about. Anyway, anywhere else in the world, we call it turning. The reason we call it turning is because the workpiece turns. When the workpiece turns, then we usually have the milling tools typically have more than one cutting edge too. In turning, the tool typically has one cutting edge, and the workpiece turns, and you move the tool through the material. And so it's really good for making axisymmetric parts. Who's used CAD software before, like SolidWorks or something like that? Most of the hands are up, right? So have you used the revolve feature? Right, you make a line and you click revolve and it goes around and it makes a solid for you. Yeah, stuff that you make using the revolve feature, probably well suited to turning on a lathe because it's an axisymmetric part. Let's see. Could you do turning in a milling machine? I guarantee you can do milling in a lathe because we have a lathe in Washburn that's got milling heads bolted into it and it's designed to do that. So you can totally do milling in a lathe. Can you do turning in a milling machine? Who was you got your hand up?
Yeah, I've seen mods where you like replace the contactors with the vertical thing.
Oh, that's different, but you could do that too. And I've actually done that several times at the company where I own, where we do that. But what I meant was you could just put the workpiece in the spindle. So if you attach the workpiece to the spindle, and then you have a cutting tool that you stick in the vise, you can totally do a turning operation in the milling machine. Sometimes we do that to make custom milling tools. So we get like a milling tool blank, put it in the spindle, and then we can make it be the shape we want it to be by putting a turning tool in a vise and just programming it as if it was a lathe, even though it's a milling machine. So the machine typically does milling. It's possible to do turning. Let's see, what else is important here? CNC machining, prototyping, manufacturing. Okay. Oh, so there's other CNC machining. Not all CNC machining is milling and turning. So milling and turning do material removal by chip formation, by large chip formation. So we're taking fairly big pieces of material and throwing them out across the machine. Who's ever used a piece of sandpaper? Yeah. That's also a machining process. And so when you're doing it like this, it's not very CNC, it's more elbow and C, right? Elbow controlled. Oh, CNC stands for computer numeric controlled. The reason we leave numeric in there is before we had computer numeric controlled machine tools, we had numeric controlled machine tools where they were programmed with a computer, but then they used these little punch cards to transfer the information to the machine tool. And so it's just like in the punch cards were either ones or zeros, right? Little on off things. So you feed them through the machine and it would do that. So they called those NC machines. Then we just said, we're wasting a lot of paper. Let's just take that computer directly up to the machine tool and make it a computer numeric controlled machine tool. They could have dropped the N at that point. They didn't. Now we're stuck with it. So CNC just means computer controlled machine tool. Not all CNC machines are mills or lathes. Grinding is like sanding. It's an abrasive process, or in sanding, it's sanding as well. You could have a CNC grinding machine, and where you're spinning the grinding wheel, you're moving the part back and forth. And so I used the extra rotary axis in my milling machine while I was using the milling machine to do a grinding operation. I actually mounted the workpiece to a rotary axis, spin it around, then have the grinding wheel and the milling holder spinning around, and then move those relative to each other. So was it a grinding operation? Was it a turning operation? Was it a milling operation? Who cares? It made the part the customer paid for. That was important. So grinding, sawing, they have CNC bandsaws. Feeds the material in, cuts it off to the length you want. Feeds the material in, cuts it off to the length you want. Most 3D printers, that like the FDM printers, the filament printers, most of them use the same kind of G-code language that a CNC mill uses. So technically, 3D printers are usually CNC machine tools. So CNC machines can be a lot of different things. In this class, we're going to focus on milling and turning. And when we do the milling, it's going to be in a milling machine. When we do the turning, it's going to be in a lathe. Okay, so manufacturing, CNC machining, prototyping. It's one of the key parts of this class, right? What is it? You guys all took the class. Most of you knew that prototyping was part of the class. So what do you got?
Making something and then figuring out what's wrong with it and then refining it.
So making something, figuring out what's wrong with it, refining it, and making it again. Is that it may be sort of a process that happens while we're doing prototyping, but is it a good definition of prototyping? Isaac, right? At least Isaac was willing to talk. What else is a good definition for prototyping? Yeah.
Creating the final iteration of a product. Or sorry, creating the first iteration of a product.
Creating an iteration of a product. How about we go with that? Because I think the final iteration of the design could be a prototype also. And so prototyping is really making something so that we could see how it's going to work. Does that make sense? So you may do prototyping. You may do a prototype production run. Purpose for a prototype production run might be to see if the production process you've designed is going to work. And if you can make multiple parts in a row, so you're prototyping the facility then. But the other real good reason to do a prototype production run is to see if anybody wants to buy your stuff, right? You make some to see if anybody wants to buy them. Who's ever had coffee from a Keurig machine? Few of you. You guys know what I mean, though, right? My data is about 5 years old, but like 5 years ago, they sold 19 billion Keurig cups a year. 19 billion Keurig cups a year. The first production run of Keurig cups, the cups cost the manufacturer $50 each. They had a theory. They had to prove that it would work. They had to prove that they could sell it. And so they were willing to pay a lot to get those production cups made, even though they couldn't possibly sell them at a profit, right? Well, yeah, no. Maybe today, maybe some collector would buy one of them for what it cost to make it. So prototyping has many reasons, but often we're doing prototyping because we don't know yet. Does that make sense? We're prototyping in order to find out, does our design work? You'll 3D print a prototype, especially if you're trying to see, do the pieces fit together and they move the way we expect them to? So people often 3D print a prototype to do that. If you want to see, does it withstand the forces that are going to be applied to it? 3D printing is often not the answer. And so we do a lot of prototyping in CNC machining. There are CNC machine shops that all they do is prototype parts. They only make one-off parts. Every part they make, they have to figure out how to make it each time. And so that can be expensive. We in our shop, we did a mix of production and prototype work, but we were often making parts that had never been made before. And so for example, we had a part that we made. It was very similar to parts we used to make. We actually quoted it based on them telling us it was very similar to parts that we used to make without having seen the drawing yet. That's trusting the customer. And then they sent us the drawing. $200,000 purchase order. First $25,000 was to deliver the first part for testing. So they give us $25,000 to figure out how to make one part. And then it was $500 a piece after that for another 200 parts or something like that. We were almost done with the first part. Called them up to ask about the drawing. And they said, that feature is not on the part. They had sent us the wrong drawing. They sent us an iteration of the part, but it wasn't the final iteration of the design. And so prototyping can be very expensive. We actually fixed it. We didn't waste the stock material. But so those things can happen. So prototyping is making the part to find out. Why do we talk so much about prototyping in this class? It's an important step of manufacturing, but that's not it. It is an important step, yeah. CNC machines are very good for prototyping, but that's not why we talk about it so much in this class. Somebody on this half of the room. I can't see them, even if they're raising their hands. Anybody? Red mask, black hat. Yeah. You need it to do anything. I like that. See, so people on this half of the classroom can speak. Yes. I would say it's not necessary, but it's a step that we typically use. But yeah, so it's probably it's a useful step. Yeah. You're getting warmer. You're getting warmer. Yeah, we're doing this. Who thinks they're gonna finish their tenure at WPI? Who thinks you graduate eventually? Well, just I mean, maybe you're just here to take this one class. Maybe you're just here for this one lecture because you heard that I'm really cool, and you wanted to see this one lecture. I don't know. So, what is the requirement all WPI students have to fulfill to graduate? Yes. This is engineering design. Yeah, specifically though, your project, your MQP. We expect most of you to come back to the manufacturing laboratories to make the parts for your MQP. And we'd like you to know something about how to do it when you come back so that you're not a pain in the ass. I mean, oh, did I say that out loud? Yeah, we'd rather have you ask more intelligent questions when you come back to work on your projects. So that's the other reason that this was a significant part of the ME1800 curriculum, was so that later when you come back, we can talk about how to make the really complex shape and we don't have to discuss what is CNC machining. So it's my ulterior motive, right? So we've got, what, like 5 minutes left? Perfect, or 10 minutes left. So again, this term I'm in charge of the labs, not the lectures. You will see me again tomorrow. Tomorrow we're going to talk specifically about lab stuff. And I'm going to talk about the CAM software we're using, how to get some resources for that and stuff. And then you have me again on Thursday, huh? We'll figure out what we're going to talk about on Thursday. Maybe tomorrow, come with suggestions, things you want to learn about on Thursday. Because Professor Brown told me that I didn't have to follow his syllabus for this first week. He said I could talk about whatever I wanted to talk about. Just kind of, we could talk about blockchain. You guys will have to teach me though. Okay, the labs. So go to m1800.com. All the lab schedule is there. I'll be adding a second page to that talks about the lab grading. So the lab syllabus is at m1800.com. Any graded assignments will be turned in on the Canvas site, just the regular Canvas site for the class. But links to all the instructions are there. If we go there now, so I'm at m1800.com here. So a bunch of you know this already, but you become a basic user. And then in our next labs, so we have Tuesday off next week, right? It's our wellness day. Yeah, so get well on Tuesday. And if you're thinking about being sick, don't get sick till then. You'll have a chance to get well. But because of the Tuesday off, the second week of the term, it really screwed up the lab schedule. Like they were not thinking about my mental wellness when they did that. So we got no labs on Monday or Tuesday next week. But we do have labs on Monday and Tuesday and Wednesday and Thursday this week. So no labs on Monday and Tuesday next week, but we do have lab the end of the week next week. And so the end of the week this week and the end of the week next week is like a week in my lab schedule. So I've made them like this instead of like this. And so what we're going to be doing is we're going to be practicing checking the distance to go on the mill. And we're going to be learning about setting offsets in the lathe. Now, when we're doing both milling and turning operations, we write these programs independent of the knowledge of which machine tool it's going to run on. We know it'll be a lathe. We don't know which lathe. We don't know how far the stock material is going to be sticking out. We don't necessarily know where the tools are. And so when we write the program, we don't know in advance all the details of the machine. So we write it with the Cartesian coordinates, basically for where the tool has to move relative to a point on the workpiece. And so then when we go to run the program, we have to tell the machine tool, where is that point on the workpiece? And also, how big are all the tools? How long are they? How far do they stick out? Things like that. And so we're going to start that. So that's setting the offsets. Once you can set the offsets, you can run a CNC machine tool and you can set up a CNC machine tool. We did this class for years where we took long-term displaced workers. We trained them to be CNC operators in 8 weeks, and then they'd go out and get a job. And we actually only had 1 week of training. In the first week, we taught them everything they needed to know to get a job. And in the following 7 weeks, we practiced so that they would be good at it when they went and got the job. But you need to know how to locate the workpiece, tell the machine how long the tools are. Of course, you need to know how to write the program. If there is no program, you won't be doing much machining, right? And so we're going to go through the writing the program stuff. And so the writing the program stuff is all this last column. The at the machine exercises are all here. We're in the process of updating all the exercises right now. But even if you, so this is the old instructions for the base. The content won't change. We're just changing the format, making it a little bit easier to see and read and navigate. So you can go through and look at any of those. And one of the changes that we're adding to all of them are the second slide in the presentation will be some pre-lab instructions that'll include a video of me doing the exercise, talking about the exercise, and some questions that you should be able to answer when you're done. This is like, what's the 5th grade word? Foreshadowing. So if you can answer all these questions, then you shouldn't have any trouble answering any of the quiz questions that I provide for the quizzes. But I probably will do that first one. What are the 6 steps? But it's a pain. Quiz questions are hard. I hate quizzes. Because you expect good quiz questions, right? At what, $250,000 to go to school here, you'd expect us to have our game on with making quiz questions? Yeah, it's hard to make good quiz questions. It's easy to make good essay questions, impossible to grade them. So there'll be some quiz questions. If you can answer these things, you should be thinking about these things. Somebody right now, though, see, today we talked about the risk of not tightening the vise sufficiently, right? Yeah. We haven't talked about what does the coolant do during the operation, and I didn't put that in the video. You can look that up. Google it. I guarantee when I make the quizzes, there are no questions you couldn't answer by Googling them. It may take you a few Google steps. Is that a thing, Google steps? Like Google Tracks? That's your history. That's Google Tracks. All right. Anyways, we go through these. And so the weekend before the labs, it's good to read the lab instructions before you're going. If there's a quiz that we're going to have you answer, we'll tell you that in advance also. But yeah, so all the stuff's here. And we have weekly assignments for the CAM exercises. Do them that week. We'll have help sessions on Wednesdays and Fridays in the lab. There'll be PLAs on staff to help you answer these questions if you get stuck. There's quiz questions that come out the week of the lab being due. The hand-in from the CAM is going to be this project, which we're reworking the project, so we haven't got the instructions for that yet. But if you finish what you're doing in lab, just do the next thing. And then maybe you'll be done early at the end of the term. That's what I got for you for today. Tomorrow, Washburn 229 at 11, I think. And we'll talk about lab stuff tomorrow.